Hello everyone and welcome to a new video on Dynamo for Alias. Today we'll be covering lists and what are lists and how they work and their basic manipulations, nested lists, and at the end we'll be covering last but not least, list at level. It's very important. Okay, so first of all, what is a list? A list is kind of, let me just show you by actually creating one. So, 10, okay, all right. And if I put a watch node, you'll see the output of that list. So here I just created a list of one value, and that value is 0. And if I add a hashtag, it'll create a list of 10 values starting from 0 and finishing by 1. So you can think of lists as basically buckets of stuff you can fill, right? And it's like imagine a bus. So if a bus has 9 seats, like a minibus, and you were able to fill those 9 seats or the X amount of seats with either people, things, or stuff, that would be a list that you would be able to send to collect and record. So it's like a record of things that you can keep track of and send to other things. I know it sounds a bit abstract, but it'll make sense in a second. So next, how do we make a list? So as I just showed you, this is one way, but there's many ways you can create lists inside of Dynamo. Okay, so if I go into my left-hand side library and click on lists and generate, we'll see that there's actually 3 ways to create lists. Let's put them all in a sequence. There we go. So we'll focus on the first one, list create. So let's say I want to add to create an item, a list, I mean, comprising of 2 items. If I click on this guy, it'll show me, oh, I can actually go here and create as many items as I want. And the way I hook things up into these items is by just simply adding a close block. So you say hello and take the guy in, and then create a second block saying my name is, put that into 2, and let's say I go here, it says hello, my name is. Right, so you basically get the idea, and you can put numbers in. So if I do 1, 2, 3, and put that into a third item, you get the idea. 1, 2, 3 here. Another way to create lists is to do a range. So start and then step. So you basically get a start value, which is, let's say, 1, and you want the end value to be 22, for example, and a step to be 4. By the way, these values are completely random, so don't put too much value in them, or faith rather. And if I copy and paste or duplicate this list, you get the idea. Starts at 1, ends at 22, but as you can see here, the last value is 21, because if you add 4 to starting from 1, if you add plus 4, you get 5, 9, 13, 17, 21. And after that, you go past the end value, which is why you don't see 22 as the last value. The way to do that, if I want to have a list that starts at 1 and finishes exactly at 22, you would have to use a sequence and not a range. So the sequence does that. Let's see if I move these over. And so my start value is 1, same as the other one. My end value, actually it's a little bit different. Let's see, the amount of numbers in a sequence. So we have 1, 2, 3, 4, 5, well, zero-based index, so 5.1 we have 6. So let's say we put 6 here. And the step would be the value, the space between the value, in this case 4. And if I did this correctly, we should see, hey, it's a little bit different. Okay, that was slightly unexpected. But anyway, let's carry on. Actually, another way I create list is I don't use these. I use the list create because sometimes it's useful to be able to just join up items that are already laid out. But actually, I never use range and sequence because I'll show you a much faster way, a much more kind of intuitive way to create lists of numbers. So let's go back to my here. As you can see, the best way is to create lists using a code block. So if I go 0, let me just type it in, 0 to 10. Let's see. Actually, you can just use that. And what that does, it creates a list with step 1 from 0 to 10. So you'll do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you get 11 values. Now, let's say we want to change that and we want to get 0.1. 0.1 will actually do the same. You get the exact same output. But if you just say, instead of 1, you put a 2, what it does is that instead of skipping the step being 1, the step becomes 2. So you only get even numbers from 0 to 10. Now, there's the third one. The third kind of shorthand or shortcut to create a list of a sequence of numbers is using the hash symbol. So let's copy and paste that one more time. And instead of 0.2, instead of 2, I put hash. And what that does is that it calculates two values based on the start and end. So obviously it's 0 and 1, but if I were to say, hey, I want, let's say, let's make it 14 values, you get exactly 14 values starting from 0 and you get 10. So you get a bunch of like really funny numbers here, but you get the idea. So that's why I don't tend to use sequence and range because they're a lot less intuitive, paradoxically, than using the shorthand. And I just tend to rely on that. And the cool thing about these code blocks, by using code blocks, is that you can rename those values arbitrarily. So let's put a third one in, and let's say you're creating a script where these values actually refer to something specific. So you want to label them correctly, right? So let's say you want a low limit and a high limit, and you want a number of points. So number of points. And you click outside. And as you can see, it tells me, okay, I'm not able to compute that because I've got variables missing. So what you do is you can use a code block again to just say, hey, I want my low limit to be 0, and click and link the two by that. Or you can also use sliders. So I want a number slider, and you can rename that. I always tend to rename things immediately because at least I know what I'm doing. And I want my high limit to be, hey, let's say 45. Anyway, doesn't matter. And my number of points tends to be a round number, so an integer. Let me just put an integer slider here. And let's go like 30. Anyway, and then put that in. And if I watch that, what do I get? Boom. and I get my list of numbers that I want. And the nice thing about having these as variables linked up to, sliders and values that you can arbitrarily choose is like, I can just go, hey, only one 8 points, and all of a sudden it calculates 8 points between, 8 points, 8 values between 0 and 45. And we could just say that's the low limit and high limit could be X values for points that we can create. And that's the cool thing about it. So let's just see if I were to say, hey, put a point by coordinate node and feed these positions, these values, as z coordinates. And as you can see, let me just go to my 3D view and zoom out. I've got a bunch of points laid out in exactly these positions. So that's basically the the basic definition of what lists are and how you can use them. And these values, they're completely arbitrary. It could be distances, it could be names, it could be anything you want. As long as it's a valid type of data, you can just use them and do cool stuff with it. So, right, what's next? Okay, next is we did this. Okay, the basics of list manipulation. Okay, so the first one is add. So what does add do? Okay, so list add. Oh, no. Okay, let me just type add. And okay, here are the two that I wanted to show you. Add item at front, add item to end. So let's take Um, let's delete a few of those so we can, it's simpler for you to understand. Right. Okay, here we go. So, list add item to end. So let's say I make an item, which is an arbitrary number, like 3.14. And I wanted to add this value at the end of that list. And as you can guess, if I take this as a list and this as my item and add a watch node at the end of that, boom, you get the idea. And yeah, so again, fairly simple concept, but it's important to show you what it can be done. And also, if I reverse these two, so let's say I want 3.14 to be my list because it's technically a list of one value, and add my original list as the item to be added, I get two lists. And that's that. I get a list within a list. And that's the basic concept of nested lists. So as you can see, that's the concept we'll be touching on later. Okay, next. Next is chop, right? Chop. Here we go. Let's chop lists. Chop. Okay. So actually, let's make it let's make this file very clean and very easy to understand. My original list. All right. Okay. So now let's say I take this list and I want to make kind of little lists of that original list. So I can, if I hover onto this, it says chop a list into a set of consecutive sublists with the specified lengths. So let's say I want my specified lengths to be, let's say 2. So let's type 2, double click, length. And again, I like things to be clean. Sorry about that. A bit of housekeeping. Right. And then you can see again a list made of sublists which are all comprised of two values. So as you can see, we started off 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here we get 5 lists, and they're all made of 1, 2, 3, 4, 5, 6, 7, 8, and the last one only contains one value because there's no 11. There's actually 11 values, so the last one is on its own. And it's pretty cool. It's pretty useful when you're trying to make, let's say, you have a bunch of points, and you wanna make that giant list of points into triangles. So you would say, hey, I want 3 points, type 3, and all of a sudden you've had 3 points per list, and it'd be a lot easier to manipulate from then on. Right, next one is clean. Okay, clean is actually a slightly funny node. Let me find an example. It's actually quite tricky to demonstrate. You know what? Okay. No, let's cover that in the next video. Count. Okay, so count is an easy concept. So it shows you if I type count and hover over the count node, it returns the number of items stored in a given list. And so as you can see, if I go here and type a watch node again to watch the contents, what does that do? It tells me there are 11 values in my original list. So as you can see, it's already there. So it's in this specific case, it's not very useful. But when I cover sublist or nested list, you'll find that it's and filter by Boolean Mask, you'll see that counting list can be really powerful because again, I can manipulate these values and do some clever stuff with it if I want to. If let's say I want the middle value of that list, then I can just say, hey, take that and let's say x. No, come on, divide and take this and divide by 2, and all of a sudden I get 5.5. And let's do a little bit of clever math. So it's actually math, not absolute, but floor, right? Because 5.5 is actually an index onto this list. So if I feed that 5.5 into floor, it gives me a 5. And that's the index. And as I'll cover in a few minutes, you can actually retrieve values at certain indexes, indices rather, and yeah, you can do a bunch of clever stuff. All right, so let's delete that. So that's what list count does. It calculates the amount of values given in a list. Right, the next one is flatten. Okay, so flatten is actually a pretty cool concept. So as you can see here, I've got lists within lists. And let's say I want to lose the structure of that list and return to the original structure that I have here. But in some cases, you can't just use the original list because it might not be there, might not be available, or you've done already quite a lot of work to get up to this point, and reconstituting an original list might just not be an available option. So what flatten does is pretty self-explanatory. It flattens a nested list of lists by a certain amount. So if I click that, and it's actually good that we can see everything with using watch nodes. As you can guess, it'll flatten everything. So you'll lose the structure. And the cool thing is, it keeps the order of that list. So it'll be completely as original. So if you compare the two, oh, sorry. If you compare the two, these are exactly same lists, and then you can choose to reorder them as you want. But flattening basically makes you discard the uh, list structure here. That's pretty cool. Okay, so now next one is remove and list remove. Oh, no, just remove maybe. Right. remove item at index. Okay, so let's say we want to remove, no, actually, let's keep it clean as originally intended. So I feed that into my list, and I want to remove the first value, the 0, and I know that 0 is at index 0. So if I double click, type 0, put that in, and as you'll see, it'll remove the first value. So I'll have lost the 0 here, and so it's a 0-based index that starts at obviously 0, finishes at 9, and now I remove the value, so that's why it only has 10 values here. If I hover onto this, and okay, no, it doesn't work. But the cool thing about indices is that I can put, I can choose to put multiple values into that. So let's say I want to remove the first and last one. I could do, there's multiple ways I can do this. So I can just create a list by, let's say I have 10. And now, as we saw earlier, I can create a list by using list create. Create. Now, put these two here and feed that list into the indices. And all of a sudden, I removed the 0 index and the index 10. So I removed 0 and 10 out of that list. As you can see, it goes from 1 to 9. Another way to create a list out of numbers is to say bracket, I believe. I might be wrong on this. Just bear with me for a second. Comma, 10, bracket right, semicolon. Looks like it's working. Here we go. And I can add another one. If I type a number that is higher than the maximum available index, let's say 123 or 123, it didn't throw an error. But if I type 3.14, which is not a round number, it still works for some reason. Okay, well, that's another way you can create lists basically. And they don't have to be in order, right? You can put 7, still works. Okay, slice is an interesting one. So if you want to slice a list, here we go. So what does that do? Returns a single sublist from a given sublist based on the starting index, end index, and step amount. Okay, so it's pretty complex, but okay. So the index to start to slice from. So I want to start at 0 because it's my first one, and I want to end at index 10. Oh, delete that. And to make it a little bit funny, let's put the step at 2 so we don't get always the same thing. And another watch node. And yeah, so not a very exciting result in this case, but you get the idea. And another one was sublist. So it's actually the sublist is a more powerful node than slice, or I shouldn't say more powerful, but more useful. So sublists. And yeah, so okay, so let me show you what it does. It's actually quite interesting. Okay. Use the same list as before. And actually, let me first put the watch node so you guys can see. All right. And I want my ranges to be 0 and let's say 2. Let's see what happens. And right, and my offset, I want them to be 1. Actually, let's make it 0 and 1. Right, as you can see, I started with a list that just says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what it did, because my offset was 1, it took the first two values, 0 and 1, and then offsetted it by 1. And then the second sublist is 1, 2, and then 2, 3, 3, 4, 5, 4, 5, 5. You get the idea, basically. And the last one is on its own because there's no second value. But if I were to say, hey, offset it by 2, it would just make a sublist, a chopped sublist based on something that we already saw here. So as you can see, offsetting by like this set of nodes that I'm dragging around and chop by actually chop by 2, not by 3. Yeah, so you can see it's exactly chopping a list by length 2 and doing sublist of offset 2 and ranges 0 and 1 is exactly the same output. I know this might sound a little bit confusing, but as I said, just keep practicing and practicing, and you'll get the hang of it, and it'll just become second nature before you know it. So I know it might seem a bit confusing, but it just practice makes perfect. Okay, next one. Take every nth item. Um, Pretty self-explanatory, but again, take a list and nth item. Let's say I want my every nth item to be, I don't know, 2. Uh, and it should work right out of the box. Here we go. So it took every nth item, nothing special. It's useful in some cases. It's useful to know that it exists and that it's there. So yeah, nothing special apparently. But when you get into very complicated list structures, it's always nice to have it available. Take items again, a simpler version of that. Up, take the original list and take 5 and there you go. That just takes the first 5 values of the original list. Again, nothing special, but comes in handy every now and again. Okay, so now we get into the meaty stuff. So, filter by Boolean Mask. Okay, let's actually I don't want to delete. Let's move that away. Oh, come on. Here we go. So it's okay. So let's say we wanted to make a list containing only the even numbers. Okay, so just 0, 2, 4, 6, 8, and 10. We could go about using a chop and slice and do some funny stuff, but it's actually quite complicated and even for fairly simple lists like here. But if you got a very long list and sometimes the conditions that you want to filter by are a little bit arbitrary, it's just not going to work. So the way you do that is by using a filter by Boolean mask. So in this instance, let's say we want to filter the even numbers. So first of all, let's start by putting a filter by Boolean mask. And so it's just bear with me for a second. It's a little bit. It might seem counterintuitive at first, but again, as I said, practice makes perfect, and you get the hang of it after using it for a while. So you get this is the list to filter, and this is the list of booleans representing a mask. So first of all, let's start with the list to filter. That's really easy. That's my list here. Up. Now we have to create a list of booleans. Okay, so a list that says 0 is true, 1 is false, 2 is true, 3 is false, 4 is true. You get the idea. False, true, false, true, false, true. All right. So how do we do that? We have to create a list that creates based on the condition that says 0 or even number is true and odd number is false. So Um, for those of you who are a bit familiar with programming, there is a node or an operator, rather, should I say, called modulo. So modulo, the kind of programming sign for it is the percentage symbol. So as I said, find the remainder, remainder of x and y. So let's say, let's use that node first of all on a separate, kind of separately. So if I were to, the remainder is, let's say I give 10, and another one I give 5 or 2. If I were to divide 10 by 2, the remainder of that is 5, is 0, because I can divide 10 by 2 and by 2 by 2. And because it's an even number, I get a 0. Okay. So what happens if, actually, let me go back. Here we go. Let's say the first value is 0, and I get a 0 for that. And if I turn into 1, you can see that the remainder is 1, because you can't divide 1 by 2 and have a full number. And again, you get the idea. If I type of 2, I can divide 2 by 2, and it's an even number. So I get the remainder that is 0, 3. I can't divide 3 by 2, so the remainder might be 1. Anyway, so now I want to do a remainder of that list based on 2, because that's the thing that's going to help me determine whether or not a value is even or odd. So go in there, I get a list of values, 0, 1, 0, 1, 0, 1, 0, 1. Okay, pretty good, getting somewhere. And I can say, okay, equals equals, which is x equals to y. So for even values, x is 0. Put that as my conditional, feed that into my list. And all of a sudden, we get what we originally intended, which was a list of booleans. And we put that into our list of booleans representing a mask. And the output of that is 2 lists. You get an in list, which satisfies the conditions that you set out in the list of Boolean masks, and an out list, which doesn't satisfy the condition. And it's highlighted in these 2 output nodes. So obviously we're not interested in the out list, we're interested in the in list, whose index is true. And that's basically it. We just filtered our list to only spit out or output the list of even numbers. Yeah, so I'll let you, let me just zoom in here. Right, so I'll let you take a screenshot of that so you guys can always refer back to it. I'll hang in there for a second. So yeah, create a list, create a list of booleans that satisfy a condition that you set out to do, obtain your list of booleans, and feed that list of booleans into your filter by Boolean mask. And after that, you get what you want. Right, next, nested lists. I think by now I've covered what list of lists are, but basically that's what it says. It's list within lists. So for instance here, we get 2 lists within a single master list. And it's useful to be able to distinguish them from other stuff. And so list that level. That's very, very important. So let's say let's start from scratch. So let's say circle. Okay, so we get a circle in the middle, and we want to create, let's say, a column of triangles, let's say. Okay, so let's create a point by coordinate, and I want to start at 0 and finish at 10, and I want to create 5 circles. So I have this point that I feed into Z. You can see my 5 points here, and these points I feed into circles, and I have 5 circles. There's a node called regular polygon, and it takes circles as input. And by default, it's drawing pentagons. I said I wanted triangles, so 3 sides. Boom, booyah. There we go. Let's disable the preview so we only see triangles. And now there's a node that retrieves the points of each polygon. So polygon. Here we go. So returns no corners. Here we go. Return corners of a polygon. Input polygon. Output point. Perfect. And now you see that I have a list of lists. And that's the definition of a nested list. And if I click on one point, here it's highlighted. If I click on the second one, it's also highlighted. The third one, highlighted. You get the idea. And the cool thing is to remember is that when you're dealing with geometry, usually the points, as long as the curves and the geometry is created in the same way, the lists of points in this instance are also ordered in the same way. So the first point in that first triangle is always on the in that facing that direction, so to speak. The first point of the second triangle, so on, so on, so on. Yeah. And let's use this example to actually illustrate a few different things. So let's say we were talking about the concept of lists at levels. So let's say we want to retrieve, to make a list only composed of the first point of each triangle. So how do we set out to do that? So we will use a get item at index, or first index rather, because if I used the index value as 0, it would be the same as this, as using the first item. So let's use that. So let's see what happens if I feed the contents into this input. It only retrieved the first 3. And I said I wanted, let me just move this around. Sorry about that. Okay. And yeah, I still have this highlighted. All right. I said I wanted the first point of each triangle. And at the moment, I've only got the 3 points from the first sublist. And that's not what I want. So there's Dynamo has this option which does a little bit of, well, clever magic. You click on this breadcrumb right here, and you can use an option called Use Levels. Okay, click on that, and as you can see, you've got a new box here, a combo box. You can modify by clicking the up and down arrows here. And as you can see, it says at level 2. So what does at level 2 mean? So if you look closely at the bottom of these lists, you can see at L1, at L2. On this one, you can see L1, L2, and L3. So L1, L2, L3, and L4, and so on and so forth, they represent the level at which you want to operate in. So if I go back to L1, it takes all the points from all the so all the triangles, which is not what we want. If I go up a level, L2, it only took the first point of the L2 level right here. And L2, like L1 is the lowest level, which is here, here, here. L2 is another level higher of lists, which basically is this 5 lists. And that's why I only get 5 points here, because I'm telling this node, retrieve the first item at level L2, and L2 is only only has 5 lists. I get 5 points. And if I go up another level at L3, it's only retrieving the first the first sublist. So yeah, basically get a lot of practice with this. Sometimes I'll show you in later videos advanced examples and applications of how to use list at levels. It's extremely powerful, and just bear in mind sometimes when you're stuck, just keep going there and just say, hey, make sure you use list at levels so that you tell the node to operate at a different list level. Anyway, okay, and I think, yeah, that's it for this episode. Make sure to comment, like, and subscribe, and share with your other Dynamo enthusiasts and Alias enthusiasts. And that's it. Thank you, and see you in a later video.